Hey everyone and welcome back. In this video, we are diving into a really powerful design principle in software architecture, the open-closed principle, specifically in the context of modern C++. Let's go step by step. The open-closed principle comes from the solid principles, 5 fundamental rules that help us write better, more maintainable software. The open-closed principle says software entities should be open for extension, but closed for modification. That sounds abstract, so let's break it down. It means that you should be able to add new behavior without changing existing code. We want to extend functionality, not modify what already works. Why is this important? Because changing working code introduces bugs. It breaks things. It's risky, especially in large code bases. If we can add features without touching existing logic, we get safer and more modular designs. Let me show you a problem that violates the open-closed principle. Imagine we are working on a simple reporting tool. We have a class that calculates area of shapes. Here is a basic version. Seems fine, right? Now, if your manager says, "Hey, we need to support triangles," what do? We go back to area calculator and add more code. This violates the open-closed principle. Every time a new shape is added, we are modifying area calculator. That's not scalable. Eventually, this class becomes bloated, and every edit risks breaking something else. Let's refactor this using polymorphism. We define a base class called shape, and each shape subclass will override a virtual method to calculate its area. Now let's make rectangle and circle inherit from shape. And now our area calculator doesn't need to care about the types of shapes at all. If we now want to add triangle, we just create a new class. No changes to area calculator. That's the open-closed principle in action. It's open for extension, we can add new shapes, but it's closed for modification. We didn't have to touch area calculator. This idea becomes even more important in real-world scenarios. Let's take a real example from a game engine. Let's say you have an entity class, and every system operates on it: rendering, physics, audio. Initially, you might hardcode some logic like this, but adding a new entity type, you modify this function again. A better design would be to define a renderable interface, and each entity implements its own render logic. Then your renderer simply calls the draw function polymorphically. This keeps your renderer untouched, even as new entity types are added. Now, there is a caveat. Sometimes the open-closed principle leads to too much abstraction, especially in C++. Virtual functions, base classes, and interface hierarchies can become over-engineered. In modern C++, there is an alternative: type erasure. Let's say you want polymorphism without inheritance. Here is a sketch using stud function. Now, any object, lambda, functor, or function can be wrapped into a renderable. You don't need a base class. This is lightweight and powerful. And it still follows the open-closed principle. You can add new types and draw logic without changing any central renderer class. So when should you apply the open-closed principle? When a module is used by many parts of the codebase. When you are expecting frequent change in features or requirements. When a system must support plugins or extensions without recompiling core logic. And when should you avoid it? If a piece of logic is unlikely to change. Don't introduce unnecessary abstraction for small, local systems where code clarity is more important than reuse. As always, it's about a balance. The goal is not to follow principles blindly, but to understand when and why they help. Let's summarize. The open-closed principle helps you write code that is easier to extend and harder to break. In C++, this often means using inheritance and virtual functions to abstract behavior, leveraging modern alternatives like type erasure or templates. designing modules to depend on interfaces, not concrete types. By following this principle, you reduce the risk of regression bugs, encourage reuse, and write more robust, flexible code. Thanks for watching. I hope this gives you a clearer picture of the open-closed principle in C++ and why it's such a valuable tool in clean software design. If you found this helpful, don't forget to like, subscribe, and check out the rest of the C++ series. See you next time.